Contoura LASIK Alcon Wavelights Topography Guided LASIK has been very popular among surgeons and patients alike since the last few years. So it all started back in 2016 when Contoura LASIK acquired FDA approval, considered as a landmark trial due to the excellent results. 65% patients achieving 20/16 vision. However, over the next 2 to 3 years, there came many different publications on Contoura LASIK from different parts of the world, each of these describing a different method of doing Contoura with a different set of protocols. It was later understood that the FDA study of 2016 had a very strict exclusion criteria and only considered eyes in which the topography cylinder and manifest cylinder were close to each other. Practically, only 15 to 20% of patients actually follow this pattern. What we normally see are eyes like this, in which the topography cylinder and manifest cylinder are very different from each other. So basically, we did not have a logical plan for doing Contoura LASIK yet. What do we use as the final refraction? We cannot use the manifest refraction since it does not take into account the higher order aberrations. We cannot use the topography modified refraction because if the cylinder is very different from the manifest, there is a risk of overcorrection. I would not want to rely on the Alcon's 50/50 protocol because it is just guesswork and playing safe without any concrete scientific foundation. So what exactly is the missing piece of the puzzle here? The higher order aberration ablation profile. If somehow we manage to get a tool which can analyze this higher order aberration profile, we will be able to answer two very important questions. The first, how does the higher order aberration ablation affect the manifest refraction? And secondly, does the higher order aberration account for the difference between the manifest cylinder and the topography cylinder? The first person to actually understand and utilize this concept has been Dr. Mark Lobanoff, who has created the 4CD's analytical engine software. So as we can see in this higher order aberration ablation map, there are these purple peripheral steep zones. These zones were given the name talus by Dr. Lobanoff, which is actually a geographical term. The 4CD's software analyzes each of these taluses by using vector mathematics and geometrical analysis, calculates the total astigmatism that the entire ablation profile causes and calls this as talus astigmatism. This actually seems like a very logical and a truly scientific way of doing Contoura LASIK. And the excellent results of the 4CD study proved just that. But then what are the problems with 4CDs? So the 4CD software needs a pentacam or any other Scheimpflug based device to measure the posterior corneal astigmatism. But the second most important problem is that there is no availability of this software in India currently. I needed to create a software that could analyze the higher order aberrations so that I didn't have to follow Alcon's rigid protocols. After months of research and development, I was finally able to create my own Contoura LASIK planning software, the iSMART Contoura LASIK. So this is a Microsoft Excel based software. This is how the primary sheet looks like. As you can see, there are 4 sheets seen below. The right eye talus and left eye talus sheets are meant for Contoura planning only. And finally, this is the nomogram sheet. Now coming back to the primary sheet, the upper green boxes are meant for patient details. So this is the space to enter the manifest refraction. This is followed by the corneal topography which has to be entered here. These two zones highlighted are meant only for Contoura planning and I will discuss these later. The pachymetry, mesopic pupil size and white to white have to be entered in these boxes respectively. The optic zone desired and the flap thickness to be entered here. You can choose the microkeratome you are using either from a Moria M2 or a SBK microkeratome. And based on all the input data, the software will tell you which is the most appropriate ring and stop size needed for the particular microkeratome selected. This is a drop-down menu for different forms of Contoura treatments, which again I will discuss a bit later. Okay, so let us take a simple case example shown here. The basic refraction, topography, pachymetry, pupil size and white to white are all already fed into the software. So when I see the patient for the first time, I immediately have the safety parameters like the ablation depth, residual stromal bed and PTA given to me by my software. As can be seen, they are all in the normal range in this case. Also, the microkeratome ring and stop size has been mentioned. In the comments box on the upper right side corner, the software now tells us that the PTA and RSB are both safe for LASIK to be done. Now once I am satisfied with everything and I want to proceed with the LASIK, I will feed the final correction in this box provided. Now I will go to the nomogram page for the nomogram sphere adjustment. As can be seen, the right eye falls in the -0.25 zone and the left eye falls in the no change zone. So I will just feed the right eye as -0.25 in this box provided. Now I will come back to the primary page and you can see the sphere and cylinder nomogram changes are indicated below the final correction. All this data is now ready to be entered into the LASIK machine. Now let us assume the right eye sphere is -8.5 instead of -6.5, and you can see immediately a message pops up that LASIK is not safe. Now in case we reduce the optic zone from 6.5 to 6 mm, again the LASIK is shown that it is safe now. If I make the optic zone still smaller to 5.5 mm, again I get a message that tells me that the optic zone is too small compared to the pupil and needs to be increased. Now once the basic understanding is done, let us see how we can plan Contoura cases using this software. For advanced planning, we need to understand this talus sheets. On the talus sheet, we can see the center and maximum ablation boxes on the top left, and the manifest refraction on the top will come automatically from the primary page. There is a box to feed for the posterior corneal astigmatism here. There is a nomogram shown here in green which can be used to enter the posterior corneal astigmatism. These boxes highlighted here are the most important part of the software because they are meant for entry of the taluses manually from the higher order aberration profile. So let us see this ablation pattern here. As we can see, there are 3 taluses. The first one appears to be at 90 degrees and is roughly 90%. Similarly, the second one is at about 60% at 165 degrees. The third one is again 60% at about 80 degrees. This is how we enter the taluses. We have also entered the posterior corneal astigmatism using the nomogram here. Now you can see the software has given us the total talus astigmatism, the total corneal astigmatism, as well as the internal astigmatism. These yellow boxes have to be seen for what recommendations to follow. They tell us that the Alcon's protocol is valid in this case and the cornea is fairly regular to use the MMR, which is the modified manifest refraction. So this is what is entered into the drop down menu of the primary page, and this will be our intended correction. So to conclude, I would just like to share some of my preliminary results using this software for Contoura.